Now, today we're going to go over z-scores. Now, of course, the first thing you're going to ask is, what's the z-score? Well, I'm going to tell you. And I'm going to pull up something so you will see what a z-score is. And we'll go here, and I'll say LBJ versus Shaq. LBJ versus Shaq z-scores. Well, I thought I had it. Hold on. Okay, where is it? There it is. Okay. This problem right here, I'll just cut it out. Now, you don't have to write it word for word, but just write down the consensus of the problem. And you want to label this set of notes z-scores. And this is probably the last couple of sections in your book, as far as 3.4, 3.5, somewhere in there. Basically, just write down the numbers. Lyndon Baines Johnson was 75 inches tall, and presidents at that time had a mean of, I'm looking for it, presidents of 71.5 inches and a standard deviation of 2.1. Shaquille is a basketball player that is 85 inches, and at that time, the height of the Boston Celtics was 80 inches and a standard deviation of 3.3. That's all you need to write down. And then the question is, which one is relatively higher or taller? Now, the key word is relatively, because any redneck with two teeth in their head will tell you that Shaquille is taller than Lyndon Baines Johnson. But that's not what the question's asking. I didn't say who is taller. I said who is relatively taller. You see, Lyndon Baines Johnson is a big fish in a little pond, where Shaq is a little fish in a what? Big pond. Because, and Shaq and little usually don't go together. But what's the qualification for being president of the United States?
Age.
Huh?
Age.
You got to have an age of what, 42 or 43? What else? Yeah, right. Oh, I'm sorry. Yeah, a citizen of the United States. That's the only two qualifications. Now, we have some exterior qualifications that we have been conditioned in the United States that have to be a lawyer or they have to be a politician. Well, that got debunked about 2 or 3 days ago, and I'm glad it did.
Well, Reagan was an actor.
Yeah, but he was a governor first. But they didn't accept Reagan the first time he ran. Okay, because he can't have him in here. He's not a politician. But anyway, I'm glad to see on both sides that that's being debunked. I'm glad to see the establishment on both sides be, what do you call it, disrupted. I don't know. Oh yeah, the qualifications. There is no qualification as far as height. I don't know who the shortest president was. You can't include FDR because FDR had what? Polio. So, and I think he was above 6 foot or 6 right at 6 foot. I don't know, but you know, people can say, well, he went from 6 foot to 4 foot. Well, yeah, he did. But the whole point is that there's no restriction, and a person of 6 foot can be a worse leader than a person of 5 foot. So height has nothing to do with the qualification to be an A. But there's no height requirement on the NBA, is there? Spud Webb was 5'5", and he could dunk a basketball. So, there's no qualification. But when you have a 6 foot 5th grader, what do you think is going to happen when that 6 foot 5th grader goes to junior high school? What do you think is going to happen? The physical education coach is going to see him, and guess what? He's going to be practicing every day at physical ed basketball, because he's 6 foot and he's a 5th grader. And they're telling him how much taller he's going to get. All right? Because an advantage of a basketball player is to be tall. And that's why it's a little fish in a big pond, is because most of your NBA players are above 6'5". All right? So, Shaquille, while he is a very tall person, does not necessarily mean that he's a big fish in a little pond. He's a little fish in a big pond. Now, which one is relatively taller? That means if you take the two and you compare them to their own population, which one is taller? Is LBJ taller in his population of presidents, or is Shaq taller in his population of basketball players? That's what the question's asking. Now, how do you do it? Well, anytime you compare apples to oranges in statistics, you use a z-score. A z-score basically takes the curve that you used to put mean and standard deviation, and it changes it to the mean of 0 and a standard deviation of 1. So write that down. A z-score system changes your mean to 0 and your standard deviation to 1. So now, instead of having a curve with your mean and standard deviation, now you're going to have a curve with what as the mean? 0 and a standard deviation of 1, 2, -1, and -2. Now, does your empirical rule still apply? Yes. 95% is going to fall between -2 and +2. Unusual is going to be between 2 and 3 and -2 and 3. And the outliers are going to be above what? 3 and below -3. So your empirical rule still applies, and the only thing that's changed is the numbers have gotten very smaller. If that's even grammatically correct. All right? Much smaller. How about much smaller? So, what do we do here? Well, we got to change these things to a z-score. We got to change all these numbers to a z-score. Or the 75 inches, we need to change it to a z-score. And the 85 inches. Well, how do you do that? Well, your z-score, these are the two formulas that you need to learn. Now, this one you need to learn for Unit 1. Z is equal to x minus x bar over standard deviation. Okay, now later, you need to remember x is equal to Oz plus mu. Now that's for later, that's chapter 6. And draw your Oz like that. That's a sigma, meaning standard deviation, times the z-score plus mu. Now, you're not going to see that in any book. That's a Hubertism, Oz plus mu. So that's for later. But this one is the one you need to, hold on a second. I'll highlight it green so y'all will highlight it in your notes. This is the one you need to use. And then put in your notes, this one is for chapter 6, I think. So, we need to make, we'll color Lyndon Baines Johnson. We'll color him red. And Shaquille is blue. So we'll do Shaquille first. Z-score, sub S, meaning Shaquille, is equal to 85. No sneezing in class. Minus 80 over 3.3. Now you need to get your calculators out. Unless you're Rain Man, you're going to need your calculator for that. And your Z-score for your LBJ is equal to 75 minus 71.5 divided by 2.1. Now, the first thing that y'all screw up, the first thing that students do is they don't read their notes, and then they just read the paragraph, and they don't do anything I just did. Okay? So I'm going to go through and I'm going to tell you what to do. The question will give you the what? The mean. There's the standard deviation. And I took those two and I put right here and right here. So I don't know how else to explain that, people. I mean, you just do what the formula says. And here's 75 inches. And that 75 goes right here. So the problem is going to give you everything. You just have to work. And you have to read, which I know is just impossible for some people. Here's your mean of 80. Standard deviation. And I highlight the standard deviation because the first thing y'all are going to do as students is y'all going to say, I don't know where everything is. Well, now you do. There's your mean and your standard deviation. And here is your X. Okay, now somebody give me the LBJ. What did y'all come out with? 1.6 what? Okay, I heard 1.6, but that last one, the enunciation just went downhill.
I have 1.67.
Thank you. For those of y'all, that's 1.67, not 1.6.
I just got 1.666.
That's 1.67. Good.
I thought you said
No, I just heard 1.6. Whoever it was, I don't know who it was. You can if you want to, or you can round it to 7. Either way. All right, 1.67, so plot it. Well, that's 1.5, so 1.67 is right in there. So there's LBJ right there. I'm trying to draw a straight line, but it turns into an oval. All right. Now, somebody give me Shaquille. 1.51. Good enunciation. Good volume. Not. Oh my gosh, I got a phone call one time in my office. And it was like, have you ever got a voicemail that you could not understand?
Yes.
Oh my gosh. I mean, it sounded like somebody was drunk. I just deleted it. 1.51. Where's 1.51? Well, this is 1.67. 1.52 is fine. It doesn't matter. There you go. Now, what's the rule? The rule is the further is The further away it is from 0, the more ER it is.
You know what it is?
ER, taller, shorter, wider, bigger, faster. Okay, so who is relatively taller? LBJ. Why? Because he is taller. He's the tallest president among the presidents, where Shaq is not the tallest basketball player among the basketball players. Pretty much. That's what it boils down to. Okay? And that's how you use z-scores. Now, later on in chapter 6, you're gonna find another way to use z-scores, but what we're doing right here is just this one. Okay? So let's find one in your homework and see what it looks like. I thought I had it pulled up, but evidently I don't. So let me pull it up right quick. Oh, I don't even know what I'm doing. There we go. That's where Hubert. Does anybody know which section I'm in? Am I in 3.4 or 3.5? Anybody look, see where the book? I'll just look at 3.5 first. See what I come up with. That's box plot. We already covered box plots. I don't want to leave that page. Let me go back. Must be 3.4. .5 is box plots, which means that's a 5-number summary.
3.4 is measures of positions and outcomes.
Why can't they just say what it is?
The z-scores on page 154.
And what section is that in?
It's in 3.4.
Yeah, here we go. Here's one. I'll blow it up because people that usually sit in the back of the room can't see. So. Okay, don't do that one. We got another. Don't do that one. We got to show you something else on that one. Hold on, let me find another one. Okay, there we go. In a certain city, the average blah, blah, blah is 72 inches. That's all we care. Mark out the 20 to 29. Mark that out. You don't need it. With a standard deviation of 3 and a mean of 72. Let's see. Where's the mean? The average is 72.5. Okay, there. I'm sorry, they give you X down there. I'm sorry. X is in a 75-inch one. There's X, and a 70-inch one. I didn't read that. I'm sorry. The X is in the second part of the question, and the mean and standard deviation is in the first part. Different book. All right, so do that one, and I want you to graph it. I want you to graph it on the bell curve, so you'll be able to understand what it means. And if you can't do it, just chalk it up as failure. So, z-score for the woman, we'll do in red. And z-score for the man, we'll do in blue. Is it okay if I say man and woman? Is that not going to offend anybody, is it? Should I say for Molly and Molly? Is that okay?
No, man, woman is just fine.
Okay. Don't know where I need to put it yet. Okay, I'm sorry. Trying to think where I came up with the word tamales. I can't remember where that came from. Okay, y'all ready for this? Just wanted to touch base with you and tell you I was out of town this week for my grandmother's funeral. The whole week. And when do you let the teacher know? When you get back. I think I would let the teacher know before I left. In some cases, it's the parent's fault. All right. I'm serious. All right, let's go with the woman. The woman is 70 inches. And 70 inches minus, what's the woman? 64.1. So 70 minus 64.1 divided by, dang old, 3.9. And the man is equal to 75 inches minus 72.5 divided by 3. And the woman comes out to be, what does it come out to be? Just 2 digits, 2 decimal places. All right, everybody say it. 1, 2, 3. Okay, did y'all understand any of that? Okay. 1 point what? 51. Thank you. 1.51. That's all right. I'm sorry, I can't hear everybody at once. All right, what about the man? Negative 0.83. It can't be because 75 minus 72.5 is a positive. Cancel that. 0.83. How about 0.83?
I like 0.83.
Does that sound better?
It does.
So we draw our handy dandy curve. As funky as it looks. 1, 2, -1, -2. And the blue one is 0.83. And the red one is 1.51. Conclusion. The woman is relatively taller. And that's how you do z-scores. Now, let's go to the problem we did a while ago, because there's another way to ask the question. And we'll use that to discourage you. All right, let's go to the problem we had a while ago. There we go. We are going to use Oz plus mu. I didn't know they put them. Like I say, it's a different book, so this book puts them together. A highly selective boarding school. What do they do? Teach boards? Will only admit students who place at least 1.5 standard deviations above the mean on a standardized test that has a mean of 200 and a standard deviation of 26. What is the minimum score that an applicant must make on the test to be accepted? First thing I would do is draw a picture. Draw a picture using the curve. Your mean is what? 200, and your standard deviation of 226 or 6. So that means first standard deviation is 226, and blah blah blah. Now, right up under those, right up under the mean of 200, I want you to put a 0, and then right up under the first standard deviation, I want you to put a 1 and a 2, and then I want you to plot 1.5. And then that way you can tell common sense wise it's going to fall between 226 and 52 or whatever it comes out to be. What's 26 plus 26? 52? 252. So I know that the score is going to fall between 226 and 252 because 1.5 falls between what? 1 and what? 2. Now how do you figure it? Well, Oz plus mu. What's sigma? Sigma S, standard deviation. What's Z? Then which in this case is what? Huh? 1.5. And then mu, mean, is what? 200. Plug and chug. I'll draw the picture while y'all are sitting in the orb of confusion.
Yeah.
Whoa. Huh? Sigma. Sigma is standard deviation. Sigma is the population parameter, remember? Parameters, population. All right, in black, I'm going to put what you're given. 200, 226, and 252. And then somebody tell me, what is that, 174? Somebody help me out. 200 minus 26. Okay, 174 minus 26. Okay. Now, right up under that, let's see if I can do this. Let's do it in a real light color, like green. I'm going to put a 0 here. I'm going to put a 1 here, and a 2 here, and a -1 here, and a -2 here. Just think of putting the z-score picture on a clear piece of paper and then putting it over this. That's basically what I'm doing. Now, our problem wants us to look at a z-score of what? 1.5, which is right here. All right? Now, I can go down here and I'll put 1.5 right here, but that's not what it's asking. It's giving us 1.5 as a z-score. But what it's asking is, at this point right here, what score represents a z-score of 1.5? What test score represents? Now, when they're asking for a test score or an age or whatever, okay, when they're asking for those things, they're asking for x. So, x is equal to Oz plus mu. Oz is sigma. The reason I say Oz is I could say sigma times z plus mu, but y'all wouldn't remember it. So I don't say that's O, I just say it looks like an O, and I say Oz plus what? Mu. So you can remember that this is the standard deviation, this is the z, and this is the mu, or the average. Or I could be mathematical and say x is equal to s times z plus x bar. Now, is there a way to remember that? No. Oz plus mu is something that I came up with a long time ago, and people remember it. Now, you're welcome to remember the other two if you want to. X is equal to s times z plus x bar. You can remember that if you want to. Or you can remember x is equal to sigma times z plus mu. You can remember that. Or you can remember Oz plus mu. Now, what is sigma? That's standard deviation. Sigma, yes, come on in whenever, that's fine. Sigma is S, right? Sigma, S. So sigma stands for the standard deviation. Standard deviation is, we said it was what? I'm looking for it, 26. Oh yeah, I had to blow it up for the people that can't see that usually sit at the back of the room. There's always one. 26 times what? 1.5. Yeah, let's all find out. Why are you late? Was it IHOP? Was the service slow or what?
I am so tired of elementary school, I could scream. I was at school.
Listen, I told my teacher, I said, he ain't coming back. I got him this week. We lazy. I'm a terrible father, so just write it off as Hubert's the father, and I'm terrible, and all y'all gonna do is sit around and watch videos all week. So
This will be the last time I take advantage of you, I promise.
mm-hmm. Next time, bring something from IHOP, okay? All right. Plus, she's trying to use that public school thing, whatever. 200 is the average. And now just go ahead and do that. Crank that out. Now, let me ask you something. What's between 226 and 252? Well, half of 26 is 13. 13 plus 226 is 239. So I think, common sense wise, it's going to be around whatever I just said a while ago. 239. What? Z. What's between 1 and 2? 1.5. That's all right. I was trying to show you that I'm overlaying the z-scores on top of these scores so you can see where this is going to fall. That's what I was trying to do. You can draw two separate graphs, or you can draw them all on top of one each other. I just put the ones below because if I put them on top, y'all would be confused then. I'm trying to show the relationship. Okay? So what's 26 times 1.5? We can do that in your head. because 26 is 1. 26 times 1 is 26. And half of 26 is 13. So that'd be, what, 39 plus 200 is 239. And that's your answer. So you put 239 in here so you can feel good about yourself. I'd love to program these questions. You suck. You got it wrong. Get a job. Quit school. I'd get fired if I was programming these questions. All right, let's look at this one. Let's see if you can. All right, let me get it back lower because I know I can't see. And I'll tell you to sit in the back left-hand corner of the room where you can't see even more. No, I'm talking about over there. That way nobody's over there. I'm not picking on anybody, but y'all trip me out how y'all pick seats in the room. The people that can see the best, they sit up front, and the people that can see the worst, they sit in the back.
I don't know what it would look like if it was. Do we have to look? Is there all scratches? We're ahead. Oh.
Yeah, I got mine broke across there.
I was doing it during class, but I was like, he's gonna call me out or something, and it's just small. Good God.
We're gonna have to pay for this electricity coming up.
Sounds like step on anything.
Hey, come on. All right, hopefully this will discourage you where you quit. A manufacturer of bolts has a quality control policy that requires it to destroy any bolts that are more than 2 standard deviations from the mean. So right then, you say to yourself, well, I need to draw me a picture because I need to try to explain this. Or you can sit there and go, well, I might as well quit. I don't know how to do it.
Is this what the test will look like?
No, I'll change the test altogether.
I mean, this kind is what.
I'm a bastard, I know.
I've been on since 5 a.m. I'm telling you.
You've been in that public school since 5
I've been
a.m.
in a public school since 7:15 this morning.
IHOP has good pancakes. Okay, so what does that first sentence say? Manufacturer makes bolts, blah blah blah, and destroys, melts them down again. Any that are more than what? 2 standard deviations. I'm going to take my handy dandy yellow highlighter and I'm going to highlight this area right here. What? my red highlighter. God, you're such a wife. Anyway. Now, what does that mean? That means that percentage, somebody tell me what that percentage is. No, well, yeah, it's unusual and outlier, but what's the percentage? 2.5%, Hubert. That's right, class. 2.5%, because that's, your empirical rule. The empirical rule says 2.5. I think it does. Look on, I think it's page 137 or something like that. Just for our information, so I'll take this out right now. So we've done that. So there's that. The quality control engineer knows that the bolts coming off the assembly line have a mean length of 13 centimeters. So we'll go down here and we'll say X bar or mu, whichever one you want to call it, is equal to 13. And sigma, or S, is equal to 0.05. I guess we're talking about 0.05 inches, centimeters. Nobody knows what that looks like. But anyway, for what lengths, so that takes care of that. So we take our handy dandy highlighter again, and we highlight through that. Well, blue, whatever. For what lengths will a bolt be destroyed? So that means they want to find that length right there. So that means we're trying to find what? X. So what's X equal? Oh no, I need to worry about all this stuff. No, you don't. I guarantee you some of y'all have started worrying about this stuff right here or whatever. You don't know those answers. But anyway, don't even look at the answers. Just do what you're supposed to. X is equal to what?
14.
X is equal to Oz plus mu. Thank you, class. Oz plus mu. Y'all just need to cooperate. X is equal to 0.05 times 13. I'm sorry. Yeah. Oh, well, I'm sorry. That's the mean. What's our 2? 2 is Z. I'm sorry. Z, 2. Plus 13. I'm not blowing this up anymore. So if you blind, you need to move to the front of the room. I'm not doing it anymore. All right. So 0.05 times 2. Well, 10% or 10% of 2 is 20. Okay, 0.2 or something like that. So it comes out to be what? 0.1, 13.1. Okay. So X is equal to, what is it, 13.1?
Yeah.
And you don't need a calculator because what's 10% of 2? 0.2, Hubert. That's right. And what's half of 10%? 5%. So what's half of 0.2? 0.1. So 13.1 is that measurement. So tell me what that means. Well, the red area is above 13.1. So what does that mean? All bolts larger than 13.1 will be melted down or something like that. Okay? Let me look and see. Let me make sure I read the question right before I... Manufacturer bolts, quality control requires it to destroy any bolts that are more than 2 standard deviations. Okay, I messed up. But didn't mess up the math. You're okay with the math. Right here. Let me get my highlighter again. This side too. We got to figure that one too. You can plug in -2. Somebody plug in -2. People, you're going to get -0.1. Don't do that. Don't punch that in on a calculator. So 12 point what? Let's see, 12 point what? 9. So this point right here is 12.9. Now I'm going to explain why I did that. Positive or negative. Put a positive or negative right here with the 2. Positive or negative. Because it doesn't say above, it says more than 2 standard deviations. That means you got to include this one too. I'm sorry. If it said greater than the 2 standard deviations, then that would be, I'm sorry, I read the question wrong. So that's that side and that side. So you're talking about 5% pretty much, but they don't want the numbers. They want to know the size of the bolt, length of the bolt. That's the word I was looking for. So at this end, it's 12.9 inches. And at this end, it's 13.1. So any bolts below 12.9 and above 13.1 is going to be destroyed. So it's going to be either A or C. Why A or C? Because they have 2 numbers. So that takes care of this. And it takes care of this. Okay, less than 13 or 12.9 and greater than. Bolts are not going to be destroyed in here because what are they? In the middle is normal, which means what? Good. So all these are green. I mean normal. So I guess you do this one right here. And you got to switch to the cursor. And that would be 12.9 and greater than 13.1. And you check so you feel good about yourself and you got it right. Okay? All right, now y'all try another one. I got to discourage you somehow. Oh yeah, this one will get you. You can quit on this one. Don't even try. Explain the meaning of the following percentiles. Now remember, percentiles is basically a mark at the percent. So draw a picture if you have to. The 10th percentile of the weight of males 36 months of age in a certain city is 13 kilograms. So they want you to explain what that means, and then they want you to explain the 95th percentile of a length of a newborn female in a certain city is 53.5, 53.3, whatever, centimeters or millimeters or whatever. Do you have a question, or are you just back there stretching? Okay. Now, I don't know, but it says the 10th percentile of the weight of males 36 months of age in a certain city is 13 kilograms. So I'm going to take my handy dandy straight line maker, and I'm just going to do something like this. And hopefully y'all are starting to see that everything revolves around this thing right here. And that you should start drawing pictures, at least in this chapter and in chapter 5 and 6. The next chapter we're going to do doing probability, and you don't have to draw this as much. Now we all know that this is 2.5% from the empirical rule. We know this is, I think, 13.1%. Y'all check me because I always forget this one. This one is 34%. This one is 34%. 13.5. Sorry. 13.5. I think that's wrong. And 2.5. Somebody look on the empirical rule. This is 11.5 or 13.5. 34 and 34 is 68. 68 and 5. Okay, it's right. 13.5. All right, somebody tell me how you get 10%. You're reading from the left because it says 10th percentile. So you read from the left. So, well, heck, that's 2.5. And this is 13.5. So what is that together? 16? Right? So 16% is right here. So half of 16 is 8%. So take this, so 8% is right in here, right? That's 8% if you divide it in half. So 10% would be where? Right about in here. I'm going to put 10%. Okay, now we drew it. Now let's take the 8% out. Now that we found it. Oh, great. Okay, it won't let me read it. All right, it says the 10th percentile of the weight of males, 36 months of age in a certain city is 13 kilograms. So at this point right here, we'll put 13 kilograms. Draw an arrow, and 13 kilograms. I have no idea what a kilogram is, but I mean I do as far as what it is, but I don't know if that's, I would assume that's small because it's on the lower end of the spectrum. That's 10%. So that means 90% is above what? 13, and 10% is below 13. Now, what does the question ask? 10% of males weigh 13 kilograms more? Nope. 10% weigh 13 more? Nope. 13 weigh less, 90 weigh more, and 10% weigh less, and 90 weigh more than. Well, I'm trying to see what the difference between C and D is. I guess and would be correct. And 90% weigh more than. Does anybody see a difference?
In D, no, it's C because in D it's just 10% of males. The person
Okay,
counts with
there it is.
36-month-old male.
Okay, thank you. They tried to get me on that one, but that's why I was thinking it was C. So answer is C. Now the next one. Draw a picture of that while I erase all this stuff right here. And erase the little marks. So this is just testing your empirical rule. It says the 95th, where is the question? I thought it was, oh, continue, sorry. I'm not used to these new questions. There we go. And I'll take my handy dandy mouse and move this over. There we go. And it says 95th percentile of the length of newborn babies is blah, blah, blah. Well, what is this right here? If this is 2.5, then what is this mark right here as far as 90-something percent? 97.5, right? So 97.5, we want 95th, so I'll say that 90, I'll put a blue mark right about there, and I'll put, what was they saying, 53.3. 53.3. So that means that 5% is above 53.3, and that means 95% is what? Below. And whichever one says that is your answer. Okay, so when it says females and males, you can just what? A is not it, and C is not it. 95 has a length of more, nope. So that leaves what? D. So this question is nothing but what? Interpretation. Interpretation of the graph and making sure you know what the graph means. It's hard to picture this unless you draw what? A picture. It does help. Okay? No, I just do it so you do extra work. That's what I do it for. A through C. I don't mind doing 3 parts. Let's do that. All right. The following graph is an ogive, whatever, of a standard standard test score. Standardized means z-score. The vertical axis in the ogive is cumulative relative frequency. Cumulative relative frequency, that means we're finding 6 blondes out of 15 people. 6 blondes out of 15 is a percentage. That's the relative frequency. So it's going to go to what? 100%. All right. The vertical axis, blah, 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 is also the complete parts A through C. Okay. So 20% had, let's just say IQ score. I don't know what this is, but 20% of the class had an IQ score of 120. 60% of the class had a score of 132, something like that. And then once you got to 160, 100% of the class, or this certain percent of the class, had that right there. Okay? So, what does it say? Find interpret the percentile rank of blah, 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 blah. Less than 130. So we take our handy dandy red marker and we find a test score of 130. There's 130. Boop. There it is. Every time I see these red dots now, I think of those red noses you put on Walgreens, you put on, no, I don't know what it is, but anyway. There it is. So 50%. So 50th percentile. I guess that's what you put here. Since the percentage of test scores are less than or equal to, did they say equal to? With a value of 130. Find and interpret the percentile with a value of 130. That means it's equal to. Okay. Well, you could say less than or greater than. Depends on what you're asking. Okay. Find and interpret the percentile of 140. So we take our blue marker and we go to 140. Then we take our handy dandy black marker and we go over here. 80%. Okay? So that's how you do that problem. I don't know what the last one says. That's the what percentile? 80th percentile and I guess less than or equal to 180 or 140. What score corresponds to the 20th percentile? Well, we go over, now we're going in reverse. We'll do this in, I'm going to take my handy dandy highlighter and I'm going to put magenta, and we go 20%, we're going to go this way. Ding! 20% made a score of what? 120. So this is nothing but interpretation and how to read a graph. And you feel good about yourself. I feel like I'm doing your homework for you. I think I am. Suppose the data represent the inch of rainfall in April for a certain city over the course of 20 years. Well, the first thing I'm going to do is what? Put it in order. And that's the first thing I'm going to do. I don't even look at anything until I put it in order. Then I'll highlight. So first hit enable editing. I hate that. Okay, move this over. Dang old hit the sort button. Dang old data. Dang old sort. Look at there. That quick. Couldn't even see it. Now, how many numbers have I got? 1 through 20. So that means I'm just going to go over here. I have no idea what it's asking for. I'm just going to go over here and do all this. I'm going to do mean, median. I'll blow it up in just a second. Mode, range, mid-range, variance, standard deviation, number, summary, min, first, second, third, and max. Okay, first of all, let me highlight this, blow it up a little bit so y'all can see. Oops, that's too much. There we go. And let's go to there we go. All right, mean. Well, that's going to be equal to summary of all these divided by 20. Is that what y'all got? Or is that what we counted? Median. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be these two guys. So I'm going to highlight those yellow. And that's equal to, parentheses, this guy plus this guy divided by 2. Mode, I really don't care. Range is equal to this guy minus this guy. I can tell you right now, you hardly going to have any modes with decimals because that tenths and hundredths is going all over the place. So I doubt you may have one because the book wants you to, but I don't really care about the mode anyway. Mid-range is equal to, parentheses, this guy plus this guy divided by what? 2, Hubert. Thank you, class. Okay, variance. Let's get on here and let's go ahead and take this guy minus this guy, F4, and copy that down. And take this guy and square it. I'm not expecting you to write all this down. I'm doing this because I'm just showing you that I'm just doing everything. Huh? No, I'm not. I'm not pulling myself, okay? I'm not doing that. I'm doing it just because it went to the Excel spreadsheet and I'm just doing it all on the Excel spreadsheet. That's why I'm doing it. Okay? Let's go with summation. And that's your numerator for your variance. And then that's going to be equal to this guy divided by n minus 1 would be 19. And then this is raised to the second power, I meant to the 0.5 power, raised to the 0.5 power. And my 5-number summary is this guy, this guy, and my mean is right here. So how many numbers are above that cross right there? 10. So I have to use number 5 and 6, right? So 1, 2, 3, 4, 5, and 6. We'll color those greenish, and that's going to be this one right here, and that's going to be equal to parentheses this guy plus this guy divided by 2, and then these two, 1, 2, 3, 4. So 5 and 6 would be right here, and we'll color those blue. And that's going to be equal to parentheses this guy plus this guy divided by 2. And we'll color that, of course, yellow. And that's yellow. And this is orange. That's orange. And maybe a rouge. Now I can do my 5-number summary. Let's do it, and then we'll look at the question and see what it's asking. So, what goes in the middle of the 5-number? I'm thinking of the. First of all, the minimum is right here, and that's that number. 1, 2, 3, 4, 5, 6 equals that number. And then the midpoint, no, I shouldn't have done 6, I should have done 7. Let me put it right here, equals this guy. It'll give us the middle number. Got the middle, no. 1, 2, 3, 4, 5, 6, 7. I was right. Dork. Sorry, I'm on drugs. All right, so this is the middle, right? There we go. And what goes in the middle of the number line? The mid-range. And then start doing half of a half of a half. And I'm just gonna, well, I did mess up. Let me delete this. And equals this. And equals this. And delete that. Alright, I'll do this because I don't do decimals very well. So this plus this divided by 2. And this plus this divided by 2. Alright, there's your number line. I screwed that up, didn't I? I-20. Let me delete it. Let's do it over. Equals parentheses this plus this divided by 2. There we go. All right, now I'm going to take this right here and I'm going to make them all in the middle so I can put the hash marks on them. There we go. And we're going to, that's the number line, so take this and we're going to do it from here to here. I'm going to put a line there, line here. There. And what's our blue is what? Our blue is 4.39. 4.39 would be right in here. And our green is 1.75, which is right in. Well, it was green. Be with you in a minute. 1.75. And yellow will give us 3.16. Ooh, right there in the middle. So what can you tell me about this data? Is it sloppy or is it tight? It's pretty tight, especially when the mean and the median or whatever falls right on the center right there. The mid-range and the median fall right there or whatever, yeah. So it's pretty tight. It looks like it's a little bit skewed to the right because most of your data is right in here. So it looks like it's a little bit, so it'd be, instead of a perfect curve, it would be more like this. Something like that with the mean being right in here. It's a little bit left, just a little bit. But anyway, that's that. And then I'll finish this over here with my mean, no yawning in class, equals the mean, and then what goes to the right equals the mean plus what? Standard deviation. Move this over here somewhere out of the way. Equals this plus the standard deviation. What happens on the left-hand side? Minus and minus. All right, so let's see what the question asks. I probably don't even know. I don't even know what it asks. Let's see. What are the quartiles? Well, we've already done the quartile 1. I may be off on the decimal places because they want you to go to 3. So I may be a little bit off. And I would not kill you on the test for that. So let's pull up. Let me move this over. Hold on a second. And pull this up. And move this over. And move this over. And then pull this over like this. And move this over like that. So our first quartile is 1.75. It's going to say wrong. Okay, good. And our second quartile is 3.165. And our third quartile is 4.39. And we feel good about ourselves. Okay, now the interquartile range I haven't went over, but it's I think the first and the second divided by something. I can't remember. Let's look and see right quick. Because I've forgotten the interquartile. Go to question help and view an example and continue. There's quartiles. There's quartile. You take the two quartiles and you divide by 2, I believe.
You take the
There it is.
third quartile and subtract the first.
There, okay, it's like the range. Okay, so take the highest and the lowest. I don't usually deal with that, but there it is. You take the third one, which is 4.39, and minus the 1.75. So the interquartile range. What do you call it? Interquartile. No sneezing in class. Interquartile range is equal to, and I'll put it right here, is equal to this guy minus this guy. And then you take that and add it to the first quartile and the second quartile, or subtract it from the first quartile and third quartile. Add it to the third quartile. In the last book, we never did do that. So, but we'll go ahead and do it here. Equals the first quartile minus this, and then the third quartile equals this. Oh, I'm sorry. This plus this. That's what you get. I'm not really worried too much about that. Simple math. It's not like rocket science. Let's see, what does that come out? Negative 0.89? I can't see for this stupid thing right here. I guess that's what it says.
Maybe you should sit closer.
Huh?
Maybe you should sit
I
closer.
can't see for this. Something's on top of it. It won't move. Oh, there it goes. All right, I'm sorry. I'm stupid. Interquartile range is 2.64. The ones at Pendleton won't move. Okay. And the lower fence is negative 0.89. I can't believe they asked for all this stuff. Oh, 1.5. I thought I did that. Quartile 1 minus 1.5. Quartile 1 minus 1.5 of the interquartile range. Is that what it's asking for?
1.5 times in the quartile.
Equals this minus 1.5 times this. Negative 2.21. Let's see if that works. Don't worry, we'll go over it again to whatever day y'all come back. And then you're going to add, this is equal to the third quartile plus 1.5 times the interquartile range, 8.35.
Where are you getting the 1.5?
That's in the formula, which I'll show it to you. I'm not going to show it to you today, though. Are there any outliers? Well, you have to see. You have to see if it's above anything below negative 2.21 and above 8.35. Is there anything above 8.35? I doubt it. I think that's the answer. Oh my gosh. Okay, this question is not going to be on your test. All right, because there's too many questions. This is too much. What are the outliers? That's why I don't like to do it. The outliers, there are no outliers. Didn't we just say that? Duh. All right. So that's how you do that. Don't worry about it. We'll go over this problem again. Just a lot of arithmetic. It's not a lot of discrete math. It's just arithmetic. Let me take the roll. Let me stop the recorder.
Got it. I got it.
Yeah.
That means I have to make it harder now.